Good day everyone and welcome back to the channel. I thought I'd get these input boards designed up before it gets to building stage, because tomorrow I think I'm going to get the polystyrene caps for my amp, and I still need to make up a board that has this 560 ohm resistor, 100 mic cap, 15k, 470 picofarad, all on a board. That board's also going to have, where this 0 volt is, there'll be basically a pad with two spaces, so a wire can link over to this 0 volt pad, and then the other side of that pad will go to a 10 ohm resistor, which will actually connect to main ground. So that board's got to have 1, 2, 3, 4, 5 components on it. It's going to be a fairly big board though, because the electrolytic capacitor is quite large, which it's going to take up half the board, and that'll leave bottom space for the smaller components. So I'm not too worried about space anyway. I'm going to get a layout on this and then I'll come back and give you all a look. Alright, so those are the components. I've just got to work out the layout now. Incidentally, the capacitors that I was saying 470 picofarad, I meant 100 picofarad. I changed that in the last video when I was going over everything. So I'll get these made up now. And well, first I'm going to mock up a drawing, and then I'm going to copy that onto board. Alright, so after mocking up, let me just lock the screen. There we go. After mocking up a quick little inline circuit, turns out it only takes up half the width of the board. So I think one of these is a bit wider than the other. No, they just cut funny. I'll take that and I'll cut it in half. I mean, yeah, it's a little bit of a squeeze, but the other option is to cut less than half and use both boards. I could make it a little bit shorter. I might do that actually. I think that's what I'm going to do. I'll keep this design, I'll squash it up a bit, and I'll cut a bit of each side of the board off. Yeah, it's a bit wasteful, but it's going to be a more accurate size that way. So that's what I'll do. Alright, well, I don't have much more planning to do, or any more planning to do. I'm not going to adjust the drawing. I'm just going to start cutting and drawing onto the PCB now. So I'll come back when this is done and we'll take it from there. Alright, I said I wasn't going to redo it, but I did just shorten it down. So yeah, that's the actual size. And that still leaves a little bit of space either side for the capacitor to actually sit on the board. So I'll get that made up now. I ended up having a long strip of circuit board that was sort of narrow, so I cut a couple pieces out of that. Yes, that one's slightly bigger, I just did it by eye. Anyway, I'm going to now make these up, and then I'll etch them, and then I'll populate them. I'll get these built all in one go now, so that the only board left to do is the main driver and input stage board when the polystyrene capacitors arrive today. Alright, well that's the design made up. It's only by freehand like I usually do. I'll go get these etched up now and then solder them up quickly. There's not really much to do here. Alright, that's the input boards done. Just going to clean the Sharpie off now. That strip on the bottom, incidentally, is so I can flood solder between there and this ground plane on the board, because the input boards are going to go on the end, so I'll be able to solder it to the end of the ground plane. You know what I just realised? I'm a dumbass. I've only made 2. I need to make another 2. I won't do them on camera because, I mean, what's the point? You'll just watch me make 2. But, God, I do stuff like this all the time. In my defense, it is a bit confusing because I'm building sort of 2 amplifiers in one case. I'm not used to that. I'm a stereo guy, so I'm kind of the 2-channel guy. But anyway. Let's get these 2 cleaned up. Beautiful. Now I just need to make another 2 because I'm a dumbass. Anyway, I think I'll go get them done off camera and then make it all up together on camera, because I'd rather get it all done at once, if that makes sense. But I won't bore you guys watching me draw them out and all that sort of stuff. And like magic, we have 2 more boards. Alright, I'm going to get these component legs formed up and then population time. Alright, I've formed up all the legs on my components because, as you know, I don't make holes on these boards, so I like to make a little flat area at the mounting area so there's more surface area. So that's ready. I'm going to tin everything up and start building the boards now. I thought I'd just quickly show you guys what I was talking about when I said this is why, although these are electrolytics, I got really good electrolytics. These you can have a look at the company online. They make capacitors specifically for audio, basically higher end capacitors. And these are audio caps. These are non-polarized caps. They're also 100 volts, so they're quite large. This is that, and the rating of them is going to give me quite a few things. It's going to give really low ESR, and what do you call it? The I've gone blank. Frequency response. The bass will be good too, because of the really large value. The other thing to note is the dissipation factor is quite low, considering it's an electrolytic. I mean, I don't know what an average electrolytic is, but I mean, let me just grab one. So I got a 47 microfarad 63 volt cap, just something you might find. A more common size and value. So there you go. That's an order of magnitude worse in terms of quality, as you can see. So before anyone has a laugh at me for using these giant caps, the reason I did is because it was that or film. I wanted to use something decent as the input capacitor, and to cut a long story short, if I try and get a 100 microfarad film cap, it's going to be, 3-4 times bigger than that. This is actually quite good. I mean, look, 0.050 dissipation factor. The capacitance is bang on. It's actually just over. It's 101.4 microfarads. And let's see what the ESR is. 0.07 of an ohm. You can't complain. at 10 kilohertz it's 0.03. Can't read it 100 kilohertz on this meter, but I mean we can look, even at 100 hertz it's half an ohm. So you know, this will make a nice input capacitor. So yeah, it is large. They do cost like $10 each or something, but maybe even more, I can't remember. But I'm trying to build an amp here that's quite high quality, and as I said, if I went the film route, it would be at least as big as this board. I mean, a 10 mic MKP film cap would be as big as this board at least, probably a bit longer actually. So yeah. Alright, well I've got all my components tinned up, so I'm going to start making these boards up. I thought I'd just talk about something. So having the input stage on a separate little board like this, or input circuit, I don't know what you want to call it. You know what I mean, not input stage as in the input transistor pair, but anyway, having it on a separate board is pretty cool, because if I decide to, say, reduce the gain of my input pair and VAS stage and buffer the input with an op amp with extra gain there, all I have to do is make up a separate little board, remove this board and put the new board with the op amp in place of this. So if you think about it, that's actually pretty cool. Anyway, something else I wanted to talk about was the diode string. Now I have mentioned that I intend on basically finding, you know, a better diode solution for the diode string that has basically a small junction capacitance and less noise with switching. I'm thinking Schottkys, but like I pointed out, I'm going to have to do some work on the thermal coefficient of them, because I'm going to need them to still track with the bias. I've been thinking, if I use Schottky diodes, what about with the diodes that are on there if I add snubbers across them? Now, I'm not going to do this yet because there's no point in doing it until the amp's built and we can actually test and listen if there's a difference. But it's just food for thought, you know. I think it's something to look into, adding a snubber across the diode string. So just wanted to mention that. I'll stop recording now and I'll get the rest of these boards made up off camera, and then I'll come back and finish the video up. This is only going to be a small video. Alright, well that's the capacitors on. I just folded them back a little bit to leave space. So these boards turned out to be just the right size, you know that? Anyway, I'll get these resistors on now. Oh goodness, I just realised something. I bent these resistor legs sort of in because I thought they went on these pads. I've just realised I'm missing 4 resistors. I actually need 560 ohm resistors as well, and I don't need these bent around like that. Oh goodness. Carefully bend these back the way I bent them, aka not the full 360 back the other way, because that would make the leg weak. Lucky for me, these are copper legs, not steel, so they do have a little bit of bend in them before they get anywhere near breaking. Yeah, if anything, it's just slightly annoying. That is the way in Dave's lab. I always manage to make a mess of something and have to go back, do it again, or whatever. We'll get there. Quite fiddly doing it this way. As soon as I get a laser printer and I can print out overlays and make my traces neater, make proper pads and all that sort of stuff, I'll drill holes and not do it this way. But at the moment, whilst I'm not drilling holes, I like doing it this way because it's quite secure, you know, like folding over the leg, leaving essentially a flat spot, sort of like a surface mount pad. It, you know, it works well. I can't knock it. It makes a very secure connection, and you know, I don't have much lead length either doing it this way, so it's pretty good. I'm not saying drilling holes gives you lead length either. I'm just saying that this works. That's all I'm saying. I'm not comparing it to anything else. Alright, I'll get these resistors installed, and I'll get those 560 ohm resistors as well. I think I'm going to do carbon film for those. I'll have a think about it. I was just sitting here getting these 560 ohm resistors formed up, and I was just thinking, I have to ask you guys, because I wouldn't mind putting some of this stuff in my amp build. I've heard that it can improve the performance. Does anyone know where I can buy snake oil? I'd like to put some snake oil in my amp. Alright, time to put the 560s on. Decided to go with carbon film. I'm not too sure. I'm weighing up Johnson noise versus inductance, and I think, I mean, once you start getting up above 100 ohms, whatever, the inductance does start to become a thing with the metal film resistors, with any resistor really. But I mean, and also when you're really down low in ohms, the noise isn't really such a problem. So we're going with carbon film for now. Alright, now I'm going to put these little 100 picofarad caps on. I originally wasn't even going to put these on. If you remember back when I first started designing this, I was like, oh, I hate putting stuff in the input path, which is true. That's why I've gone with a very high quality cap and a very small value. If I get AM radio interference, I'll increase the value of the cap. That's something to be wary of for anyone that's playing along at home, is that if you make that cap value too small and your input acts like an antenna, you can pick up radio. You can pick up other things too if there was no cap there, or the cap was really, really small. But it just depends. It also depends about with other things inside the amp, and the performance of the amp, the gain, the bandwidth. There's a lot of things that come into play, but yeah, just something to be wary of. Like I said, I've gone with 100 picofarads because it's going to, with the 15k resistor across it, filter at about 100 kilohertz, which is 5 times the bandwidth of the amp. And usually when you're building an amp, that's like any amp, not just an audio amp, but when you're building a high quality amp, that's usually the rule. If there's going to be bandwidth limiting or something that's limiting the bandwidth, it should be at least 5 times below the usable bandwidth of the amplifier or device that is being limited. So that's why I've arrived at that figure. Other people, I've seen some people do the 100 kilohertz way like I've done. I've seen other people go with 20 kilohertz. I've seen other people go with 40 kilohertz or 44 kilohertz, something like that. I can't remember. Probably about 40. I don't think anyone's going to bother getting an exact value capacitor. But yeah, you know, I mean, obviously an R and a C that forms the network, so it's not just the capacitor value, but you know what I'm saying. Alright, lucky last. But these are fiddly. Alright, that's that. Now for these resistors, these are the 10 ohms that connect that ground over to the main ground. The other thing I need to do is I need to add a little piece of coax here at the end. This pad here is for the shield of the coax, because the other end of the coax, only the wire connects to the base of the transistor, but it needs to be shielded up to where the wire comes out. So that's why there's two pads here. One's for the shield, one's for the signal. And I can do that now too, because I've got, you know what, I'll leave it because I've still got wires on the output stage to make up, and I've got to make up a wiring loom. So I'll leave all the wiring for one day, you know, just like I've done everything else in parts. I'll leave all the wiring for one day, but that's what's going to happen. There's going to be a little piece of coax that goes from there to the base of the transistor, and it will be shielded, and the shield will be attached to there. Yeah, I kind of take these things fairly seriously. Well, that's one board complete. Two boards complete. Three. Well, that's it. So that's the 4 input boards complete and ready. Alright, you know what? I'll do the coax now. Why not? That way they're ready to attach. I guess. Oh, that's something I've got to tell you guys. I had a few emails come in about stuff that I've got deliveries coming. My capacitors are either going to be here tomorrow or Monday. So, yeah, this amp's getting built in just a couple of days at the latest. So the way this is going to work, that pad there, I think it's that pad, hold on. Oh goodness, looking at this, it's so confusing. What have I done? I'm going to have to think about this for a minute. Alright, I think I'll work this out. I think that's one base from negative feedback, and that's the other base. So that pad there is where our signal's got to go to. So that pad, same on the other two boards. And this board is going to be like that. So, well, actually, to be accurate, it's going to be like that. But anyway, signal comes out of here, needs to get to, it's bugger all. if I should even bother shielding it. I mean, it just doesn't seem any point. It's that close. I mean, what's the point in shielding it when all the rest of this is still acting as an antenna, you know what I mean? It's not really going to make a difference. Although you do have your RF filter right here, so yeah. I don't know. I feel like it's a little bit wanky doing that, you know? But I've already got this trace here at the same time. I don't know, I'm going to have a think about this. I had to think about it. And no, I'm not going to use coax for that little piece. But that pad is still quite useful because I need to join the... How do I explain it? It's really hard because I'm not laying the board out, so I can't remember exactly where everything is. But somewhere around here, there's there's the compensation network, and then there's negative feedback network. The end of the negative feedback network has components that go to ground, and that's just a pad, one of these pads. That has to get connected to that pad there because it needs to be connected to audio ground, not ground. So actually, these boards are perfect how they are. They just need to get soldered that strip to that strip, so the board will be standing up like that. One wire goes from there to there, and the other wire goes from there to somewhere around here. Simple. So that is the input boards complete. I literally have to just wait for capacitors, and then I can put this thing together. You don't know how good that feels. I'm going to leave that video here, but I thought I'd just end the video giving you a look at the giant ass collection that I have to put in a box. That too. But wow. This is what you call a big project. Anyway, thanks for watching, and I will see you all soon.